Hello. So this is the annual Tube Open Movie Project presentation. And NVIDIA just started its settings. We can just quit that. And now my presentation is gone. That's nice. Here we go. OK. So just a brief introduction. Tube is an open movie project with pretty similar type of setup as the open movie projects done by the Blender Foundation. It differs that it's set up by artists and it's not actually run by the Blender Foundation, of course. It's running currently at Hampshire College in Massachusetts as kind of a joint educational venture. We have a lot of interns working on the project doing various tasks. The Tube is the name of the project, which is kind of what it always was. And recently we finally released the title of the film, which is Wires for Empathy. And it's a short film about the epic of, based on the epic of Gilgamesh, I should say. And I'm going to play the trailer, and hopefully nothing will go wrong, because, it probably will go wrong. So we'll see. Hopefully it has sound. Okay, the kind of level of work we had been doing up to the release of the trailer, which was at SIGGRAPH this year, was kind of the standard things in animation production. We have modeling, texturing, animation, lighting and rendering, some compositing, and this is all kind of things that didn't require much or too much R&D effort for the project. The kind of things that we didn't do yet or didn't complete yet, in some cases we did a lot but didn't finish it, is kind of the hard stuff. So everything that required a little bit of thinking ahead of time. And so we have various elements of this, like we have you can pick many, but I'll mention a few. We have some crowd scenes, so we have to deal with large groups of characters on screen. We have time-lapse sequences, so we have to kind of animate our entire background and set and textures, and everything becomes up for grabs for animation. So sets stop being this kind of static thing that's just sitting on screen. And yeah, we have also like some other issues. For instance, we joke that this is a zombie movie. There's some gore in it, and we hadn't. So we had to do some stuff for that, and you're about to see it. So let's move on to the first topic, which is crowds. And this is a terribly in-progress rendered shot. Please don't judge too hard. And this is one way in which we are sort of handling crowds by keeping them out of focus. But it's it's still a bunch of work. They still are models. They have to be rigged and animated, and we had to fill that shot. And the problem with that shot is because it's a shallow focus shot, it's a long lens, and you kind of see all the characters sort of the same size behind the character. And it took more characters than we thought to actually fill the kind of feeling of having like a real crowd behind her. So originally drew some concepts that were like kind of outlines for what the characters could look like, and then we started making more of these. And then we sent these, I basically would scribble them in half an hour and send them to a modeler who's doing low poly work. His name is Hassan Yola. Hi, Hassan. And he has a very quick ability to like just follow the thing. And then, you know, we needed more characters, so he just made a few almost without concepts. And in the end, it still didn't fill the crowd. So the final kind of concept that I made that he modeled, I decided to do some work with. So let's hope this works, because I wasn't realizing that I'd had only a 640 by 480 display. So I'll hit enter, and Blender will start on this screen, which you can't see. And let's see if I can actually get my mouse back. Yeah, my mouse has actually disappeared. So the demo bits are going to go really badly because oh, now it says thanks for watching. That's neat. So here we go. The mouse is weirdly disappearing and reappearing. So great. So just a minute. I'm going to quit the demo application, and this all is going to hell. So we're going to try to use Blender. In such a small display. There we go. So this is going to be really confusing for me, I think. But the main thing is that maybe I can make this screen full. So with the full screen, it's not so bad. And yeah, here we go. So this character, yeah, that's wide. Oops. Okay. All right. So this character was the final one he made, and basically what I needed was a way for the animators, when they were like filling in characters and adding in like some crowd scene animation, to be able to just add a character and not basically ask me, I need a character, okay, draw a concept, send it to the guy, have him model it, get it back, put the rig in it, and give it to them, and that takes like a bunch of time. And so we made this final character. By the way, all the characters have names from the Epic of Gilgamesh, so they have names like Urshanabi and Utnapishtim and Siduri. So I called this guy Stanabi, which just means standard Abi, and I gave him some. So the rig's really simple, and I gave him some little sliders. So if we go to rendered, we can see some of them. For instance, you can change the color of his clothes. Something will change here. Oh yeah, so this is like some little set things. If you go back to, yeah. So the color can change. The biggest kind of changer is to change the hairstyle. So there's like a variety of little hairstyles. You can change the neck width, where the mouth is, and like stuff like that. Head size can be changed. This is actually quite handy. I can't quite see what I'm doing right now, but it's if you want to make a kid, you just lower the height and you make the head size bigger, and you like maybe there's a soften one somewhere here that I can't see. All right, here. So you can kind of soften the features, and then you have a little kid, and like you can make a family, and they can have some nice hipster glasses, you know. So basically that's it. And the animators have a button, and they can press in theory, they can press the button, and then you get a new character, and then you go and start animating it and tweak its shape. In practice, you press the button, you get a new character, and you can do that. Then you have to make sure to save and reload your file before you press the button again. So that's just like how it works in real life, you know. So that's the standard kind of character thing. So now that I've demoed that, I'm going to go back to the presentation mode. This was supposed to be so smooth, and Yeah, of course it isn't. So back here, let's start that. And now I have to speed through those slides. Okay, so demo, and now, all right, so let's go to the demo one. Let's see if I can get it to full screen. Okay, so we're going to show some of the time-lapse stuff. And so I won't give away any of the story reasons behind the time-lapse, just to kind of like keep some surprises for actually watching the movie. But there's quite an extended part of the movie about maybe like a little bit more than 1/3 of the film, where like pretty much every shot you see is a time lapse. So you don't have just the character moving around, you have the whole set changing. And I'm going to show some of our early, we just kind of started with the stuff. So yeah, go to the next slide, please. Oh, yeah, I know what's happened. There we go. So this is OpenGL of some ruined buildings that are deteriorating over time and settling, and grass is growing and stuff like that. This is a time lapse of a cockroach that's dead, that's rotting. It's the same cockroach you saw in the trailer. This is also a shot from the trailer. You can see some of the textures getting a little bit older. Here's a shot that's not in the trailer and it's not finished. So we have like, the fun part of this is the kind of like the train is, to get the kind of motion blur train, it's actually a modeled piece of mesh with some texture on it that has the flashes. And the crowds are not done yet. Right now I only have one character that's being duplicated, but the idea is to have multiple different blurs that are being instanced by a particle system. And the posters are actually going to be replaced by a scripted solution that uses particles and then instances objects that can have like unique textures and animations over the life of the particle. So yeah, and this was going to be a demo. I shudder as to what's going to happen. I'll hit enter, and yeah, it starts Blender in the wrong screen again. Okay, and I'm going to lose my mouse again. Yeah, everything is going exactly as supposed to be. So this is just to show that that shot that you saw. That was the one with the train. So this is, for instance, the train. If I go to rendered, you can see it's just like a simple mesh, and they basically have some kind of randomized disappearing or appearing thing going on in front of the screen, and they also kind of move. Let's see. I kind of forgot where I am in the file. Okay, so let's go to camera view. And so each individual asset has its own kind of time-lapse rig set up. For instance, this thing here, which you, let's see if I can select it and go into local view. Yeah, I don't have my Wacom with me, so I don't have the buttons that I mapped. So now I have to do this. So where's local view? Okay, we'll skip local view. But basically, this has a rig that deteriorates. Here, I'll get out of camera so we don't have the camera motion. So it's actually rigged to kind of sag and pieces fall off over time. So a lot of the assets that we initially built for the first scene that were just these static assets, now we have to go back to each one and start rigging it. And it's relatively simple stuff. I actually have a YouTube video somewhere about doing some of it. You basically use everything you can, shape keys, modifiers. Lattice is a cheap way to get everything to kind of sag together, so use that often. Hooks, animated constraints, so you can have a curve with some things on it, and they're hooked to it, and they have an animated constraint to their fallen position. So if there's if there's an object on a wire, and then it like falls, so it just suddenly goes from being here to being on the ground like that. And so you want kind of a combination of things that are smoothly moving over time, like, a wire is sagging, or, things like sagging and wear and tear are happening smoothly, but now and then you want sort of a mini catastrophic event where something fell or got broken, and so it's there in one frame and it's gone in the next, or it's in one position in one frame and it's in a totally different position in the next frame, to kind of give kind of a combination of the kind of smooth motion and staccato changes that are kind of typical of time-lapse stuff. So I'm going to cut the demo short because it's actually really hard to do it like this. I was kind of hoping that I would have, mirrored displays and be able to see my laptop, but it just couldn't detect the projector properly. If Linus Torvalds were here, he would be giving NVIDIA the finger, and yeah, okay. And so getting into one of the big issues with the time-lapse thing, it becomes a problem with textures. So it's not enough to you can paint a perfectly detailed image texture and put it on an object and you think you're done. But in our case, we kind of needed textures to go from being sort of new, not brand new, but not terribly old, to becoming ruinously old and ancient, or maybe want to have the appearance that, and by the way, we haven't done this part yet. For instance, if you have a wall and people are putting posters on it, and then you want the texture of the wall to change, because there used to be a poster on it, so you have a clean bit and a dark bit. And I think we're going to do some of that with dynamic paint. However, the textures themselves are nodal shaders and cycles. And Nicolo, who's here, and I think he's going to take over from me in 1 second, has done some pretty complex shader trees. And basically, he'll tell us that this node on the shader tree is time, and so basically, if you animate this one, it will age the whole tree. We both have done that, and you can play tricks with gradients a lot. So this is kind of a hack to make things like cracks growing if you don't want to do dynamic paint for everything. If you paint gradients along the shape, and you can do this in GIMP with some fill tools, and you can do that in the R, G, and B channels, so you can get different channels for this, and you feed that into a color ramp, and so this gradient is going into a color ramp, and then you can animate the color ramp, which, because it doesn't expose the position on the node, you have to kind of dig in the outliner to get that position property so you can key it or drive it. But when you animate that color ramp, it sort of animates where on the gradient the crack is. So if you have a crack that goes from 100% red to 0% red along the length of the crack, and then you have a color ramp that animates that white bar, the crack looks like it's growing. And if you have a ton of those in your texture, you can have cracks that are growing, and then you can make solid colors, and those will just suddenly appear at one point. So you can have bits of the paint fall off simply by having a small irregular shape that's a solid a solid non-gradient color, and then at some point the ramp position will go past it and it will show up and expose a different texture underneath it. And some of it is different techniques, and so I'm going to hand over the mic to Nicola, and he's going to talk to you about the challenges of texturing, because texturing is also something that we did late in the project, and that's kind of had some interest. So you can just use the right and left arrow key to advance the slides.
Okay, yeah, just quickly a few interesting points about the textures and the shading that I've been doing for the last 10 months in Tube. And yeah, the point in time when you do shading was probably the most interesting thing to see. Also in comparison with what happened in Mango, which was different because of practical reasons, the timing and how the schedule was organized. There, at least the shading I did was done before doing any lighting, which sounds very reasonable. You model, texture, then light. But actually doing a good shader that works in every situation is a lot more iterations than you might think. And instead, the case in Tube where I generally had, I was working on an asset and I had generally 3 or more shots with potentially final lighting in clay materials to test. That was incredibly easier for me as a shader artist to work with. And what would happen generally was that like 2 shots were working fine, predictably, with the shader I made in the first iteration. The third shot would be weird, like having too much glossy, too little glossy. The bump would look twice as strong than the other shots, and that would mean 1 or 2 more iterations just tweaking the shaders, getting it to work with all of the 3 shots. But it's still a lot less than the maybe 15 iterations you might need to get the shader working in every case. And out of the probably something like 15, 20 shots I've seen the lighting for and used to test the assets, there was only one where I kindly proposed the fact, gently tried to propose the idea that would go back to lighting because it would totally blown out and not really something, I mean, it was the lighting that was out of scale. In the other cases, it was depending on how many shots and how different they are, more iterations of the shader, and to get it working right in every case. And then the types of textures for the time-lapse aspect, I started working with dirt maps and shaders with lots of nodes and blending anyway, because that's what I've been doing, like a personal project way of texturing. And the particular thing about Tube in this case, I didn't use the batch-based script much, and I unpainted all of the dirt maps for all of the assets. But this is going to be useful for the time-lapse, and so far there are the way the first test time-lapse material were done was just adding a value node and plug it into some of the controls, the mix factors already existing in the node material, and then you get the change in time. There is much more, like what Bassam was saying before, there are many more possibilities for the time-lapse. But when you have a complex node tree material, making it time-lapse is the base version is just adding a value node and plug it into the right blending parameters to change the blending. But also another kind of texturing, I've been working a lot with dirt maps and maybe too little with photographs generally. And in this case, a lot of time and a big part was played by, I would call kits of textures. Those kind of textures like tiles and bricks that you are going to reuse a lot. And if you have a good one, then you can make all the variants you need. And so it's sometimes something I'm learning is sometimes it's worth spending very long time on a texture, like sculpting, taking many photographs, using, you can see above a sculpt for the tiles, and below that node tree is used to mix various photo textures with random mixes by different tiles. So I'm using Cycles node to output a texture that is going to get into another Cycles material in the end. But it's just the like a compositing system to composite different textures and randomize them by element, so that every tile has a slightly different color, slightly different pattern, and every really. For this kind of highly reusable textures, there's no limit to the amount of work you can do and the amount of types of techniques you can use to get the definitive brick textures that then you can reuse for years. Like this is another sculpt. And a test scene for these herringbone bricks that are going to be in the station. And last point, this is a node shader. Probably this is like when a node shader gets too complicated for performance, for the performance aspect. I'm not going to go into detail now, but I'll try to talk, and everyone who's interested to talk about it, I'd be happy to talk later or in the other talks. I have some questions to ask about performance. The thing that I'm focusing on and I need to test more is basically 4 variables, 2 sets of variables. That is the complexity of the node tree. So for time-lapse, or even the reason why I use dirt maps and such a complex node tree is just because it's really quick to iterate, make changes, check the lighting, and it's just easier for the shading artist to do revisions. You do a revision in a fraction of a second instead of saving, reloading, restarting everything. And it's good for time-lapse, but it's heavy. So the alternative would be doing something like this, and then bake everything down to 3 textures: diffuse, specular, and normal. So this is one variable, a complex node tree or a baked shader. And the other variable is using progressive or branched in Cycles. I would need a lot more data points to say something for sure. But I've seen so far that using progressive, the difference in performance was significant, like 150%, 200% render time. Keeping in mind this is probably already a bit too complex. You can get away with a simpler shader than this number of nodes. While then switching to branched in Cycles, the general render time for the test I did was half of the progressive in general. And also the difference between using a baked shader and this kind of complex node tree was only around 5 or 10%. Which it's something that seems to be the pattern, but it needs a lot more testing. So if anyone has already done this kind of research or wants to talk about it, we can talk later.
This is one of the results. This is actually one of the shots in the trailer, but if you compare it to the trailer, it looks much better. The textures are, I think, at this point, a mix from Pere Balzac and some other ones, maybe even some of mine, some of Nicolo's, and he did the final shader work for it, and it kind of boosted the look of the shot a lot. One thing that Nicolo didn't mention, but it's an interesting thing as well, is that you can have great shaders in one item, one asset, and then you put it in a scene with another asset, and suddenly they don't fit together anymore. One is like much more bright than the other or something like that. So you spend a lot of time going back and forth and sort of calibrating the kind of overall reflectance of your things to like kind of match each other. And I think in this one, it's not quite obvious, but we didn't have any speck on the stones in the trailer shot. And so the tracks were really kind of like specky, but the stones had no reflection at all, and it looked kind of odd kind of CG, and this has even the tiny little highlights on the stones here, and in some angles it's much more obvious. So we're going into our issue of Gore. So that's a very simple example of it, with a hand that's bleeding. But we actually have a lot more severe kind of gore going on in the movie. So this is a concept for what happens to our character. So this is just a MyPaint sketch that I did, and I sent to, among a lot of other MyPaint sketches from different angles, and I sent them to Dmitry Kalinin, who's kind of our sort of a high poly character modeler for the show. So like Hassan's doing kind of the low poly characters, and Dimitri's doing all the high poly modeling. So he does a lot of sculpting, and he does a lot of retopology. I think in the recent one, he might have used a little bit of the contour retopology tool in some places. I don't know for sure, but I think he did. I think he tested it. So he would take these and he would sculpt them into like a character model. This is just a close-up of Gore that's on the kind of the side. This is kind of an in 3D view. It doesn't actually show off the sculpt very well because you don't see the displacement map here. So he would basically retopologize, bake displacement, and you get you get more resolution with that. And of course, a Gore character has to move. So we have some animation reference shot by our anim supervisor and me, kind of like showing and action. Showing kind of how the action. So sort of gives you an idea. And here's a rendered version of, without textures yet, of that Gore sculpt that Dmitry did. You can see it's just a screenshot of the, there's a nice little 3D cursor that she's looking at the bottom. Hopefully we can sneak it into the movie somewhere as an Easter egg. So yeah, that's kind of our Gore. And to give you an idea of the scope, there's actually like 5 different shots where you have sort of different kinds of dismemberment, and they're actually totally different models. We have 2 of them modeled and rigged. One of them is being animated right now. And then we have like one that's modeled but not rigged, and the other one's in the process of being sculpted. So like basically they have to kind of be built together. And then there's another shot that I'm basically going to take pretty much all of our Gore stuff and kit bash it together and get like, for that shot, it's a kind of a time-lapse Gore thing, so like it makes sense to use different ones. One of the cool things too is that we have a full skeleton for Gilgamesh. So one of the things that Dmitry modeled is this gorgeous skeleton, which I forgot to include a slide of. And it's going to be used for some of those Gore time-lapse shots. I'm also going to use it in compositing and actually have these kind of hazy, glowy, kind of almost X-ray thing happens in some shots. So it's kind of cool. I'm not going to show any scripts because you just look at a bunch of code. But I just want to mention some of the like bigger, so we have lots and lots and lots of small scripts and add-on in Tube. And yeah, I'm almost done. And we also have a few kind of big ones for us. Big ones mean that like it's maybe over 1,000 lines of code. So the first one is reference desk, and we're trying to find some shorter names for things. So reference desk is written by Chris Weber, who's somewhere around here. Hi, Chris. So he wrote this thing. It basically is an asset manager. So we have, I've shown it off before. It basically allows you to, it has a small descriptor file that lives in your project, in the root of the project. And basically, when you use the add-on, you can load that file up, and then when you want an asset, you just click on a button, and you get the asset. And the nice thing is that it's very customizable, and so each asset will typically have a little bit of Python in there too, so that when you click the button, it loads the data, and then it runs the Python on it too. So for instance, if you want a character for an animator, you click the button, and you get the character, but it's been, the proxy has been made, it's been parented to the proxy rig, it's been placed in the right layer because we have a standard layer convention, and it's been put into pose mode. And that layer has been revealed if it was already hidden. And so the animator is ready to just like start posing it or something like that. For the station, there's like hundreds of small objects that make up the entire set. So if you want to load the station set, you have to load these hundreds of small objects, and to fit them exactly into the positions next to each other that need to live in. Because this was exorbitant, we had a script that recorded all the object positions, and then when you press the button, it loads the assets from different files and instantiates the groups and then puts them all at the right positions, so you get everything kind of in the right place and you don't have to be like moving stuff around and snapping it. And then you kind of build it up from the parts by pressing the button, and typically then you delete the stuff you don't need because the camera is only looking at one part of the set. Another script that is similar to that for a different set lets you draw a cube and then press a button, and it puts the bits of the set that fit inside this cube. And the rest of it doesn't get displayed. Or delete the stuff that's inside the cube is also a possibility. The auto walker is for not the crowd scene that you saw, because actually those characters don't have legs, they're just torsos, and they kind of move around like this. But for characters that have legs that you see all together, right now in Blender we don't have a really good way of putting characters on paths anymore. We kind of lost that between 2.49 and 2.5 and never got it back. So it was kind of punted to being a rig problem, but I think we never did that in rigs. So this is kind of a script that lets you, once again, have characters moving on complex paths based on walk cycles. And it does some kind of neat stuff. And then we actually wrote our own layer manager because dealing with cryptic buttons was too hard. It does cool things. There's, I think, a YouTube video for it too. Anyway, Layla is my current short name for it. I think it's kind of cute. Okay, and so that really brings us to the end of the stuff that I'm going to talk about. I'm going to take questions, and while I take questions, I'm going to just pace through some blooper slides, and so you can see what happens when things go wrong. Gilgamesh loses her skin, and you can just jump in and ask any questions as you have while I'm playing this kind of little blooper stuff. The question was, do I plan to release any of the scripts? Some of them actually are already out there. We blogged them or posted them somewhere, and without too much fanfare. I'd like to propose some of them for inclusion into Contrib, because some of them are kind of really special purpose, but some of them are general enough that you can use them for any project and are kind of being written with that in mind. For instance, reference desk could be a really cool thing to include with an asset CD. So if you add all your assets into that descriptor file, then browsing the CD becomes something that you can do from inside of Blender to just get the assets you need into your file. So they all kind of have some uses. The short answer is yes. And of course, when we release the movie, we're going to do the whole DVD with everything on it. And because of that, you'll have all of the scripts as well, and they're all GPL licensed, I think, the same as the ones that are included inside of Blender. Something is going to happen here. You just have to wait, because the animation just didn't happen, but one thing did, and this is called the Gandalf. I swear something will happen. Just keep your eyes glued on the screen. It's going to be so awesome. I hope. Okay, now I'm having doubts. Maybe it doesn't happen anymore. We're going to skip to the next slide. Oh, but we won't, because it's... Oh, I think what happened is it crashed the presentation program. But I can... And feel free to ask questions while I'm messing around with broken assets over here. It's let's just go to the next one. So it's basically a bunch of different things. The UI is actually really written lazily to just pick up any properties you stick on a certain control in the character and like display them as a slider. And then the actual stuff, it's creating, Python scripts have like, not Python scripts, but like if you define properties in Python, you can give them like special getters and setters and update functions and stuff like that. So you can you can store a bunch of meshes with fake users, and basically when you change the property, it'll call an update function, and it will change. We will swap out the mesh for the thing. And the rest of it is more standard stuff, like driving bone scales or driving shape keys and stuff like that. Pretty much the usual thing there. This was really neat. We had this rig working perfectly, and then I parented her to an escalator, and that happened. This is some great hair sim moments. You always have to have great hair sim moments in blooper reels. It gets better. It's kind of awesome abstract art, I think, More loopy sand, great arms. I think I really love the arms in this shot, just.
How many frames and what's the average time?
How many frames? Well, I mean, it's about 12 minutes long. It's 24 frames per second. So however many that is. So render time, it varies a lot, and I don't really have like a very strict. Obviously, if something's going to take like 10 hours to render a single frame, we're going to try to change something. But like some of them take 40 minutes, some of them take more, some of them take less per frame per node, and then we have a render farm, so you can get your whole shot out overnight most of the time. Yeah. Is there an estimated release date? I am not at liberty to disclose this, actually. Seriously, I can't. There's some plans that are in progress that we haven't quite decided, and it's not just us in the team. Like, we're talking to other people about it, and so until like everything is perfectly laid out, I guess just like I hope to say, expect some big news soon about this, but I just and I wish I could have came out and said the plan here, but it's just I haven't finished talking about it with people, so yeah. But yeah, I think you're gonna see something interesting happen pretty soon. Yeah. That's a really hard question. I guess so long as there are some people doing activity all the time, at least me, then and if I don't fail completely at communication, it's possible to get people working together. It's very hard to do things remote. Let's put it that way. And so part of that plan is to try to get more people in one place than we have ever attempted before in the project to try to finish it. The biggest problem, I think, is that people don't have time, because if someone's good, they're very busy, and if someone's kind of more beginner, I won't say not good, then they have more free time, but it takes them longer to do things. And so you kind of have this balance between those things. So that's, yeah. Okay, so this is it. Thanks, Francesco. No, actually, standing on your shoulder. It was pretty much everything but the I needed to have